So in this video we're going to be looking at the AQA additional physics topic of momentum. And momentum is the tendency of a moving object to keep moving in the same direction. So you need to understand that momentum only applies to moving objects, and the calculations will involve objects which are already moving or objects which are about to move. And you will be calculating them, what happens after they start moving. So momentum means that it's very hard to change the direction of an object which has a lot of momentum. And so if you think about a car which is driving very fast, it's also a very heavy object and so has a lot of momentum. And when you're driving a fast car, it's very difficult to turn. This is why racing drivers have to brake before they take a turn. Also, when you're driving a very heavy vehicle, it's more difficult to turn than when you're driving a lighter vehicle. And the reason that balls find it difficult to turn when they're charging is due to their momentum. And momentum is worked out by this equation here, which we'll be using later. Momentum, which is worked out in kilograms per meters per second, equals the mass of the object you're talking about in kilograms times velocity in meters per second. And notice that velocity is used rather than speed. And the reason we use velocity is because direction is very important, because momentum is the tendency of an object to keep moving in the same direction, and speed doesn't take into account direction, but velocity does. And we abbreviate this equation with the symbols P for momentum, M for mass, and V for velocity. And we can transpose this into a maths triangle, which you may find helpful. P on the top, mass and velocity on the bottom. So say we wanted to work out mass using momentum and velocity, we cover mass up and we see we need to divide momentum by velocity. As I've already stated, direction is very important in momentum, and so direction affects momentum. So momentum can change when the direction of the object changes, as well as speed and mass. But the most important concept to take away from this slide is that momentum is conserved when there is a collision event or an explosion or any event involving momentum. For example, if we have a speeding car which crashes into a stationary car, such as in my drawing here of the green car which is moving at a very high speed, and it's about to crash into a blue car which is standing still. Momentum is conserved because when the speeding car crashes, it will lose a lot of speed. And this momentum will be transferred to the speeding car, which may get pushed in the direction of the speeding car. And in this way, momentum is conserved. In the next video, we'll be going over momentum calculations, which may be the most difficult calculations you will find in the additional physics topics. But once you follow the steps, it isn't as difficult to do. Thank you.